Hi everyone, in this video I'm going to give you a strategy for graphing logarithmic functions. If you're curious about how this strategy works, watch the video at the bottom of the page called Why Does Graphing Logarithmic Functions Work This Way? So let's go ahead and get started. The key behind our strategy is that the expression y equals log base a of x is equivalent to the expression x equals a to the y. So you saw in those last two videos how to convert between logarithmic form and exponential form. That's the key to this whole strategy for graphing. So if we want to graph y equals log base a of x, that's our function, we're first going to graph y equals a to the x and then reflect it over y equals x. This should sound familiar from when we talked about inverse functions. The graph of the inverse of a function is just the reflection over y equals x. So basically we're saying the graph of log base a of x is the graph of the inverse of y equals a to the x. We'll make this more explicit in later videos. But let's go ahead and use this strategy to graph y equals log base 2 of x. So the first thing I'm going to do is to graph y equals 2 to the x, the exponential function. So I'll make my function table. If x is -1, then I'm doing 2 to the -1, so that's a half. If x is 0, I'm doing 2 to the 0, so that's 1. If x is 1, 2 to the 1 is 2. X is 2, 2 to the 2 is 4, and let's go up to x being 3. 2 to the 3 is 8. So now I'll graph this function. Maybe I'll use pink to do it. So -1 comma 1/2, 0 comma 1, 1 comma 2, 2 comma 4, and 3 comma 1, 2, 3, 4, 5, 6, 7, 8. Oops, this was supposed to be here at 1/2. So now to graph the inverse, you'll remember from our unit on inverse functions, when I switch the y and the x, I basically just use the opposite function table. So when I plug in a half, my output should be -1. I'm switching the y and the x. When I plug in 1, my output is 0. When I plug in 2, my output is 1. When I plug in 4, my output is 2. When I plug in 8, my output is 3. So now I can graph this function, and it turns out to just be, as we said, the reflection over the line y equals x. So let's make sure I'm drawing this line in correctly. So there's y equals x, and I put in 1/2 comma -1, 1 comma 0 is the reflection of that point, 2 comma 1 is the reflection of this point, 4 comma 2 is the reflection of that, and 8 comma 3 is the reflection of that one. So the graph of log base 2 of x is this blue one. And so you can notice some properties. The horizontal asymptote from the exponent graph, when we reflected it, it turned into a vertical asymptote of the blue graph, the log graph. Well, let's list some properties as we go. So the asymptote that we have is a vertical asymptote at x equals 0. If you look at the graph, you'll see that the domain of this function is all x greater than 0. If I plug in a -x, that means that I raised a positive number to a power and got a negative. That can't happen. And so the domain has to be all numbers greater than 0. The range is going to be all real numbers. And you'll notice that the domain of the pink graph of our inverse was all reals, and the range was all numbers greater than 0. So the domain of the original function becomes the range of the inverse. The range of the inverse becomes the domain of our new function. All right, the y-intercept, well, there is none for the log graph because, as you can see, we never cross the y-axis. We have a vertical asymptote there. And the x-intercept is the value when y is 0, so that's 1 comma 0. No matter what base, all this is saying is that log of 1, no matter what the base is, so log of 1 will always be 0. And we'll see that property in the next video. So the graph of a logarithmic function, if we follow all of these properties, it's going to have an x-intercept here and a vertical asymptote there, and it's going to be increasing, so it will always look something like that. And you can always find the graph of a log function by first graphing its inverse. So y equals a to the x. In our example, it was y equals 2 to the x. You get this pink graph, reflect it to get your new graph. More algebraically, you get the function table for 2 to the x, then you can get the function table for log base 2 just by reversing the roles of x and y. So that's the basics for graphing logarithmic functions. You'll see how all of this fits into the properties of logs and the way that we evaluate logs in the next couple videos. But this should get you started.